Hello everyone, welcome to Eduxcite classes. Today we will continue from the last video where we solved from 4.1 to 4.3. If you have not watched that video, please go through it. The link is given in the description below. Okay. Today we will solve 4.4 and 4.5. So it's a small request to all to please solve this worksheet before watching this video. You can download the worksheet in the QR code given, or you can get the link in the description as well. So please solve that first and then watch this video for the solution. Okay. So without wasting time, let us start with the very first question. So the question says a light is traveling from water to air. So we know that water is what? A denser as compared to air. So we can say the light is traveling from a denser to a rarer medium. This is your rarer. So denser to rarer. So we know that when a light is traveling from denser to rarer, what happens? It bends towards the normal. Okay. But here the question is asking in terms of Snell's law. And we know that Snell's law is already given in your data booklet, which is sin I by sin R is equals to a constant that is nothing but your refractive index. So here the angle of incidence is always measured with the normal. So this is your angle of incidence, which is W, and this is your angle of refraction. So your equation comes like sin W over sin Y is equals to constant. Okay. So sin W equals to constant into sin Y, which is option D. Okay. Question number 2. Please make a note, those who don't know, that whenever you are dealing with any wave, when it is traveling from one medium to another or the other medium, the one quantity which does not change is your frequency. So frequency never changes, it remains same. Okay. So already your option B and C get incorrect. Now we know the equation of wave is V equals to F times lambda. Lambda is your wavelength. So if frequency is constant, so V by lambda, the ratio of V by lambda has to be equal. Now the light is passing from air to glass. Now air is your rarer and glass is your denser. So from when a light is traveling from rare to denser, we know that the speed of the light decreases. So the speed of the light decreases when it moves from rarer to denser. The wavelength will also decrease in the same manner. So this will decrease, this will also decrease, option A. Okay. So this point is very important to understand here, that the frequency will never change. Now question number 3. A sound wave moves faster in warm air. Again, this is your rarer and this is your denser, cold air. The diagram below shows plane waves in cold air moving towards a boundary with warm air. So this is your cold air and this is your warm air. We have to identify which arrow shows the possible direction of the waves. Now we know that from when a ray is traveling from rare to denser, it moves away from the normal. So if you see the diagram given, you can see that the light is traveling in this direction. So, and this is your normal. So it will move away from the normal like this. So which is option, the third one, which is option C. Okay. Now question number 4 again, which of the following diagram best shows the path of a ray of monochromatic light through a glass prism in air? So here it is air, then glass, and then air. So the direct way is, we know that from again rare to denser, away from normal, and denser to rarer, towards normal. Okay. So let us see the first diagram. So this is the incident ray. So you can imagine, let us say this is my normal, somewhat like this. It will be like this. So it has to go like straight, but it will bend towards the normal, that is rarer, and this is denser. So it moves towards the normal. Now again this is the normal only, so this cannot be the option. So now it is moving from denser to rarer, so it will move like this is the direction, it will move away from the normal like this. Okay. So which is clearly shown by the option B. So this is your correct answer. Why this is not the option? Because if the line is parallel with the base of the prism, So this angle and this angle has to be equal. Okay, only when this is parallel with the your base of the prism. Okay, so option B is the right answer. Okay, now question number 5. So this is a medium x, this is the boundary, and this is medium y. One information is given that the speed of wave is greater in medium x than in medium y. So we can say greater means this is what, rarer, and this is what, denser. So when again a ray is moving from rare to denser, these are the wavefront and this is the direction of incident wave. So what will happen? It will have to go like this, but it will bend towards the normal, and let us say this is the normal. So it will bend towards the normal, so your rays will be somewhat like this. Now why I have decreased the wavelength? Because we know that when a speed of x is greater than speed of y, so frequency times lambda, frequency times lambda of y, lambda of frequency does not change, so lambda of x will be greater than lambda of y. So lambda of y has to be, this is lambda of y, has to be smaller than this lambda x. Okay, so which is clearly shown by the option A. So this is your right answer for question number 5. Okay, so if you have any doubt, you can comment below, or you can download the PDF where I am solving like this. You can download the PDF of this and the link description below, or you might have seen a QR code in the beginning of this video. If you scan that QR code, then also you can download the PDF. Okay, now question number 6. Now in such type of question, a pulse is traveling a straight along attached to a wall. Now we see that this is what, a wall, so it is a fixed. So when a wave is directing towards a fixed end, so it will get inverted. Okay, so inverted always draw a parallel like this, so it will be somewhat like this shape after reflection from the fixed end, so which is clearly shown by the option A. So always get inverted from a fixed end. This is the answer. Okay, rest all are your incorrect. Okay, because otherwise you can see like this part is reflecting first, so this will be away from the wall after reflection, and this part is coming later, so this will be here. Or you can just draw a parallel line meeting the pattern. Question number 7 is a very good question. So you see here a string is held horizontally with one end attached to a fixed support. Now again here it is mentioned that if this is a fixed support, now two pulses are created on the free end like this. This is the first and this is the second pulse. The pulses are moving towards the fixed support as shown in the diagram. Which one of the following is a possible subsequent picture of the string? Now I will let you know with the help of a PHET simulation. Okay, now just pay attention, I have already made this type of arrangement here. Now you just see this is the first and this is the second. Now I am just starting it. You just observe. Now this is the case. Rest all, you can pause the video and you can check. I am just running the simulation. Here you can see at the just before the fixed end, when the these disturbance meet. Okay, after now just now this one. Okay, so at this particular point I will pause once again. Just let me this one. So at this one what happens is the displacement of both the pulses gets added just before one is reflecting and one is moving towards the fixed end. So this is the only possible case. Okay, that is one of your option. Rest all are not possible. So you can just replay this simulation and you can check. So this is the only possible equation pattern that we can get. Okay, so only option C is the right answer. This won't be possible. This is also not possible. This is possible here. Okay, you might have seen in the, or you can go back and check again. So this is also not possible. Now the phenomena of diffraction is associated with what? All types of waves. Diffraction happens with all waves. It is not only with sound or light, it happens with all waves. And the condition. Now the next question is the condition of diffraction. A bat is approaching towards an insect with a span length d. The bat emits a sound wave. The bat detects the insect if the sound is reflected from the insect. Which insect will not be located? Now for the reflection, it has to be the length span should be very large. But if this is very small as compared to the wavelength of the sound, then the diffraction will takes place. So it is not be located means the rays gets diffracted from this. So that is only possible when the length of d is much smaller than the length. This is the condition of diffraction, that the size of the obstacle should be very less or comparable to the size of the wavelength. So not possible means it has to pass through it. It means should get diffracted. Therefore, it should not reflect back. Okay. Now question number 10, again diffraction. If the waves are coming and this is the obstacle, so the around the edges it will get corner. Okay, so option A is your right answer. I don't think anyone will be having confusion in this. Now the Young's double slit experiment, very famous experiment. Now you see this is a single slit, this is a double slit, and this is a monochromatic light source. What is the function of the single slit? What is function of this? It is used to create a coherent source, okay, to produce a coherent source at S1 and S2, so that they are in coherent and in the same phase. Okay, next question is which condition is essential for the interference? So interference, you should have a constant phase difference between the wave. That is the direct question. Okay, so you have to remember this. Now question number 30 is quite interesting. This is again a double slit arrangement. Produces bright and dark fringes on the screen near point P as indicated. The light from the two slits have equal amplitude as of now. Which one of the following gives the change, if any, in the appearance of the bright and the dark fringes when the amplitude of the light wave from one slit is reduced? Now let us say if the amplitude of the light is reduced here. So at this point, let us say it is bright fringe. Okay, so bright is happening when they are meeting at the same point, or the crest and the trough are interfering. So let us say this is the reduced in amplitude and this is the actual amplitude before reducing. So initially they both were like this, so we are getting more brightness, but now one is reduced, so the bright fringe, the brightness will become less. So this is incorrect, this is incorrect. Now for the dark fringe, now dark fringe is formed when one is crest and one is trough. Okay, so they are getting cancelling out and we got a dark fringe. Now one is the same and the other is reduced, so you will get a bit of more bright dark fringe. Okay, so it becomes more bright and becomes less bright. Option C is the right answer. Okay, now question number 14, how to solve these questions. Okay, there are two identical sources in a ripple tank generate waves of wavelength lambda. So wavelength lambda are forming by the water waves. The interfering waves produce the wave pattern which is shown below, along which of the labeled lines, you can see these are the labeled lines, is the path difference between the wave from the source is equals to 1.5 lambda. Okay, so always remember what in such type of, just draw middle line straight from mid of the sources. Now compare here. So we know that this is, let us say, one line. So this is the second line passing through the pattern of the wave. So this is what? This is your one wavelength. So this is your one wavelength. So 1.5 is simply this is 0.5. So this complete gives you a wide span of 1.5 lambda, that is option 3. Rest all you cannot say 1.5. This is lambda, this is 2 lambda, and this is also something around 2.5 lambda. Okay, Now question number 15 again. A water wave of wavelength 2 meter is produced by the two sources S1 and S2. The sources vibrate in phase. The point S1 is 1 meter from point P and S2 is 3 meter. S1 alone and S2 alone produce each a wave of amplitude A at P. So let us say this is the amplitude, assuming like this. These are the same phase. Okay, so both are meeting in the same phase, so the amplitude will get, displacement will get add. So A plus A at point P will becomes 2A. So the resultant wave at point P, where S1 and S2 both emitting waves, will be 2A. Okay, so this is how you can solve. So wavelength is 2 meters, so you can say this is the half wavelength and this is 1.5 wavelength. So both will meet in the same phase, so the amplitude will get added up, so it will get 2A. Okay. Now starting with the 4.5, the last part, that is your standing waves. So standing waves in an open pipe come as a result of, so in an open pipe you might have seen the reflection as well as the superposition takes place. Option A. For a standing wave, all the particles between two successive nodes. Now when we say these are the two successive nodes like this, they have what? Amplitude only. There is no amplitude, okay, in the two nodes. So frequency, have the same frequency, yes, between, okay, all particles like this. So there are n number of particles, so assuming, so they have different amplitudes, so it's incorrect. Yeah, frequency, they will be the same because they all have the same time period. So you can say, yeah, they have the same frequency. So this is also incorrect. Energy is not transferred. Okay. So option B only. Question number 3. Which of the one of the following is correct? For the transfer of energy along a, we know that there is no transfer of energy in a standing wave. The particles are at their own position only. So yeah, so this is incorrect. This is incorrect. Now we have to select from A and B. So amplitude, as I mentioned, every particle is having a different amplitude. So a varies amplitude and no energy transfer. Option B is the right answer. Now question number 4. The standing wave is established on a string between two fixed points. So these are the two fixed points. At the instant shown that point T is moving downward. So if this is moving downward, this will move upward. So this point U will move downward. Option D is the right answer. Okay. Question number 5. There are two particles X and Y which are situated half a wavelength apart on a stationary wave of wavelength lambda. The variation with time t of the displacement dx of X is shown. So this is the particle X with respect to time, and the particle Y is half wavelength. So half wavelength means it will start from here. So it will be like this. This pattern is shown by option A only. Okay. If you have any doubt, you can comment below. Now question number 6. The diagram below represents the fundamental first harmonic of a sound inside a given pipe. Which of the following correctly represent the displacement of point P and Q? Now you see this is a sound wave. Okay. And sound wave is a type of longitudinal. So the displacement of the particles will be along the direction of the wave travel, that is parallel. So C and D are incorrect. So you can see P has a less amplitude, so the displacement will be less, whereas Q has a larger amplitude. So option A is the right answer. Okay, because it's a sound wave. Now question number 7. A pipe open at both ends. So let us say this is a pipe which is open at both ends, and we know that whenever there is an open, so what will form? The nodes will be, antinodes will be forming. And when there is a close, so this is like an antinode and first harmonic. So first harmonic is something like, just a second, let me draw it. Something like this. So this is an antinode, this is an antinode, and L is the length of the pipe. So this is L, and we know that between one node and one antinode, the distance is lambda by 4 in terms of lambda. So this is lambda by 4 and this is also lambda by 4. So can I get a relation between L is 2 times of lambda by 4, which is lambda by 2, or lambda is equals to 2L. Okay, now using V equals to F lambda. Now we know that frequency we have to find out. Okay, so frequency is equals to V by lambda. So V by lambda is 2L. So the answer is V by 2L. This is incorrect because this is not dimensionally correct. Not correct dimensions, because we know that frequency has to be in per second. Okay, this is not again possible. This is 4 and this is not also. So option A is the right answer. Now question number 8. A string with both ends fixed. So you can see here nodes are forming to vibrate in the second harmonic mode as shown by the dashed line. So this was the first harmonic and this was the second harmonic. The solid line shows a photograph of a string at a particular instant of time of the second harmonic. Okay, 2 points on the have been marked, point P and point Q. Okay, which of the following correctly compares both the period of the vibration P and Q and the average speed? So we know that the frequency is constant, so the time period will also be constant. So C and D are your incorrect answer. Now if this time period is constant, so V is equals to F lambda, it means frequency is constant. Okay, and so for the second harmonic, for each particle they have to be of different sorry, this can't be here. So we can say with same period, if I want to complete in the same period all the particles, so they might have a different speed. So the particles at the antinodes will have the maximum speed and the particles near the nodes will have less speed. So they have different speed and same period. Option B is the right answer. Okay. Question number 9. Two pipes P and Q of the same length. Let us draw it. P is closed at one end. So let us say this is P, which is closed at one end, and Q is open at both ends of the same length. Let us say this is Q. So at P, the fundamental frequency will be like this: antinodes at the closed end and nodes at the antinodes at the open end and nodes at the closed end. So this is the first fundamental frequency of point. So let us say this is length L, this is also length L, and here it will be forming like this. It will be forming like this. So here I can say this is lambda by 4 again, and this is also lambda by 4 again, and this is again lambda by 4. So here L is equals to lambda by 4, so we get lambda is equals to 4L. So V equals to F lambda. So F1, that is the fundamental frequency, will be V by lambda, which is V by 4L, whose value is 220. Now for this case, L is equals to lambda by 2, so lambda is equals to 2L. So V is equals to F lambda. So F1 for this will be V by lambda, which is 2L. So V by 4L is 220. So if I multiply this 2 and this 2, so this becomes 2 times of 220, which is 440 Hertz. Okay, so the option B is the right answer. So this is how you have to think. There will be no ratification, no memorization. You can just do it with the basics. Always remember, at the end there will be node formation. Okay, here always it will be a node, and here it always be an antinode on the open side. So here antinode, node, node. Okay, sorry, antinode. So compare the length of the pipe with the formation. Always remember, the lambda by 4 is between nodes and antinodes, and between two antinodes it will be lambda by 2, or between two nodes. Okay, So this is how you have to solve. Okay, now question number 10 is quite interesting. So a tube is filled with water and a vibrating tuning fork is held above its open end. The tap at the base of the water is open. The water runs out. The sound is loudest when the water level is at X. So when the water level is at X, you can say an antinode is forming at the open end and a node is forming like this. Okay. Now in the second case, this is the first case. Now in the second case, again a loud sound is heard when the water level is at distance y. So when the water level is at distance y, assuming, let us say, okay, so this will be the case because this is the closed end. Okay, so here it is closed end, so it will form a node here. This will be the node, so this will be the second loud sound. Okay, now you see here, if you minus this length, so y minus x is this much only, and we know that this length is what, lambda by 2. Okay, so if this is lambda by 2, then lambda by 2 is equals to y minus x. So lambda is equals to 2 times of y minus x, which is option D. Okay, if you have not understood, please let me know in the comment box. I will try again. Now question number 11 is quite simple. So this is the, you can say any you can consider, let us say this is the closed end, so node is forming, so this is the distance between the nodes. This is one node, this is the second node, and so D is equals to lambda by 2. So we have to find out the frequency of the source. So V is equals to f lambda. Okay, so f will be V by lambda, so V by lambda is V by 2 D. So option A is the right answer. Okay, simple. Now again question number 12 and the last question of the video. The vibrating tuning fork is held above the tube which is filled with water. The water gradually runs out of the tube until a maximum loudness of the sound is heard. Which of the following best shows the standing wave pattern set in the, so always remember, whenever you want to hear the maximum loudness of the sound, in that case it should always form an antinode, okay, at that point. So this is incorrect, this is incorrect. Now we have to select for A and C. So maximum sound and the AND part should be the node. So this is node, this not possible, option C only. So this is the case, always remember. Question number 12. So I hope I have cleared all your doubts. If you have further any doubt, please comment below, and if you like this video, please share with your classmates so that it reaches to the maximum. Thank you and keep learning.